We talked about pointers in the previous part of this course, but I want to do a quick refresher here because we'll be working with pointers again in this part of the course. So all the rectangle objects we have created so far were on the stack, which is a part of memory that automatically gets cleaned up when our objects go out of scope. So when the main function finishes execution, this rectangle variable will go out of scope, so the destructor of the rectangle object gets called, and then after, the memory allocated to this object will be freed automatically. Now, objects on the stack are useful when they are local to a function, so we don't need them outside of a function. But sometimes we need an object to stay in memory after a function finishes execution. In those cases, we need to create that object on the heap or the free store using the new operator. So we type new rectangle. Now, if you want to initialize this with some values, we open parentheses and pass values to the constructor. Let's say 10 and 20 for the width and the height. Now, this returns a rectangle pointer, so we can store it in a variable like this. Now, we can simplify this code by using the auto keyword here. That is better. Now, we have a pointer, so we can use the arrow operator to access the members of this object. So we can draw this rectangle on the terminal. Now, when we are done with this object, we have to delete this pointer. We have to free up the memory that was allocated on the heap. So here we use the delete operator and free up the memory. And then we set this pointer to null pointer. Otherwise, we'll have a pointer pointing to a memory address that doesn't exist anymore. We refer to that as a dangling pointer. If we forget to free up the memory and reset the pointer, our program will have a memory leak. So it's going to take up some memory, but it will never release that memory. So in modern C++, we shouldn't really use the new and delete operators anymore. Instead, we should use smart pointers. The great thing about smart pointers is that they will take care of freeing up the memory using their destructor. So we don't have to worry about doing this. So let's see how we can rewrite this code using a smart pointer. First, we go on the top and include the memory header file. Now, let me remove all this code. So in this file, we have two types of pointers, unique pointer and shared pointer. The difference between these two pointers is that a unique pointer takes the ownership of an object. So we cannot have two unique pointers pointing to the same object in memory. In contrast with shared pointers, we can have multiple pointers pointing to the same object. Now here I'm going to create a unique pointer. So we're going to use a helper function called makeUnique. Now in angle brackets, we have to specify the type of object we want to create, which is what? Rectangle. Now, if you want to initialize this with some values, we pass them here, so 10 and 20. These values will be sent to the constructor of this rectangle. Now, this returns a unique pointer object, so we can store it in a variable like this. Okay? So the type of this object is unique pointer of rectangle. Now, just like before, we can use the arrow operator to access the members of this object. Now, the beautiful thing about smart pointers is that we don't have to worry about deleting them. So there is no such a thing as delete rectangle. So we use a smart pointer just like a regular variable. When the main function finishes execution, this rectangle variable is going to go out of scope. So the destructor of this object is going to get called, and that's where the memory gets released. So that was a quick refresher about pointers. We'll get back to pointers again later in the course. So you know how smart pointers work in C++. Now, it would be fun to create a smart pointer class from scratch because this helps you better understand how smart pointers work. Once you understand how something really works, then it's no longer complicated. So as your exercise, I want you to define a class called smart pointer. In this class, we have an attribute of type integer pointer. So this class, unlike the unique pointer in C++, can only hold integer pointers. In the future, I will show you how to make this generic so we can store any kind of pointer here. Now, in this class, we need a constructor for initializing this pointer. So when we create a smart pointer object, we pass an integer pointer to the constructor of this class. Now, in this class, we also need a destructor, and this is where we release the memory using the delete operator. So we delete the pointer and reset it to null pointer. This is how smart pointers work in C++. So spend a few minutes on this You might think this is complicated, but trust me, it's much easier than you think. If you spend a couple of minutes on this, I'm pretty sure you can solve this problem on your own. And if not, that's totally fine. Remember, you're a student, you're learning, so don't be hard on yourself. So spend a couple of minutes on this and then come back see my solution. All right, so back to our project. Let's add a new class called Smart Pointer. Now, in this class, we need to store an integer pointer. So in the private section, let's declare an attribute. Now, we should initialize this using a constructor. So in the public section, we add a constructor that takes an integer pointer. Now, we should make this explicit as a best practice and generate the definition. Now, here we can use a member initializer list to initialize our attribute. Good. Next, we need to declare a destructor for freeing up the memory. So over here, we add a destructor, smart pointer. Now let's generate the definition. Okay, this is where we use the delete operator to delete this pointer and free up the memory. And then we should set this to null pointer. Now let's use this in our main file. So first, we include the smart pointer header file. Now, in the past, we used the new operator to allocate an object on the heap. So we could declare an integer on the heap and we would get an integer pointer. Now, instead of this, we're going to use our smart pointer. So we create a smart pointer object and we initialize it with this expression. So we create an integer pointer and pass it to the constructor of this class. Now, the beautiful thing about this design is that we don't have to worry about releasing the memory using the delete operator. When the main function finishes execution, this variable will go out of scope. At that point, the destructor is called and our pointer is released. This is how smart pointers work in C++. But the smart pointer we have created here is very simple. It doesn't have any features. For example, it doesn't have the indirection operator. It doesn't have the arrow operator. In the next section, we'll talk about operator overloading, so we can come back and enhance this pointer class.